Hi, I'm Vedika from Group 8 and I'll be going through the Excel spreadsheet. Task 1 was to create a multiple linear regression model to predict the number of daily deaths in various countries due to COVID-19. The general form to predict this is y is equal to beta naught plus beta 1 x1 plus beta 2 x2, so on till beta n xn. The original data set consisted of a large number of data points, some of which were blank, so we cleaned it up and finally obtained a training data set of 2,100 data points from 70 countries and a testing data set of the rest. Data points were collected between 5th October and 5th November 2021 to be relevant to the current situation and also to acquire a manageable set of data points. Taking new deaths smoothed as a dependent variable, we selected independent variables according to their relationship with new deaths smoothed as shown in these graphs. Next, we used Data Analysis Toolpak to obtain the following metrics. Predictors were determined on the basis of these values. Significance F was less than 0.5 and p-values were less than 0.15. Using these predictors, we were able to obtain beta naught values, and using this, we were able to obtain predicted values, and from there, we found errors and mean square errors.
At the start of task 1 for Python, we actually imported the functions from cohort and homework week 9, and then we subsequently created a function that models the linear regression so that we can compare with Excel. This model takes in the alpha value, the beta value, the number of iterations, the feature parameters here. It also takes in the CSV file and the target column of new death smoothed. Afterwards, we actually return the three metrics that we want to use: the predicted values, the target test value, and the features test. So afterwards, we actually calculated the metrics for our model, so it is very similar to what we have in Excel. Afterwards, we plot the individual features against the target values and predicted values. So we do so first by making a model with only one of the features individually. So we did for every single one. And after that, with the features test, we actually use the target and the predicted values as our targets to see the difference between the values and the trend that they are showing. So for task 2, our problem statement is that given a rise in COVID-19 cases, the Singaporean government will always take the necessary precautions to prevent an unprecedented rise in COVID-19 transmission. This increases the stringency index significantly as workplaces and school closes. In such a case, what would be the stringency index of Singapore be? So what we aim to do in this model is that given the current conditions of what Singapore might be in the future, we want to use the past to be able to determine what the stringency index of Singapore would be at that time. So this is the data we've used and why we used it. See, these are some of the models and the features that we considered. And this is the reason why that we thought it would be good. So first we started out by importing the data set. Then afterwards we import the functions from week 9. And then we created another model, big model to calculate this stringency index. So it similarly takes in the alpha value, beta value iterations. The start value here is to slice the rows in the data set to make sure that we get a better range of values, same as the n, and this is the feature parameters that we are taking in, and the target column is the stringency index. So for our initial model, this is how we did it, and then this is the metrics that we managed to calculate for our initial model. So moving on to improving our model, we evaluated 5 different things. So firstly, we evaluated using the entire data set versus using only specific values. So this one is using all the values, data points that Singapore has from the start of 2020 all the way to currently. For this one, we actually only extracted the targeted data set that we think is more relevant for the our training model. So actually we took the cases that Singapore is only exposed to COVID, so it's about February of 2020. So next we went on to test the alpha values, which is the learning rate, and then as we can see here that the learning rate of 0.01 causes a much lower mean squared error value than compared to 0.001. So we decided to take this as our alpha value. And for beta value, we actually tested these different beta values, and we concluded that there's really not much difference in the mean square error. So we still decided to take this value because it produces the lowest mean square error. So to test the optimal number of iterations, we actually used a wide range of numbers. And then as we can see from the value here, it's only at number 16, which is 3,300, where we could actually get the optimal minimum number of iterations to get up to 2 decimal place accuracy. So number 16, 3,300, we get up to 2 decimal places of accuracy. So lastly, we test the optimal features that we wanted to consider. So we actually made a model for successive cases. So for the first one, we actually did for total cases. Then the second model we did for these two, so total cases and new cases. For the third model, we did for total cases, new cases, and then new cases smoothed, so on and so forth. So how we evaluated the model is that we came up with this chart. It shows that the MSE value as the number of features increase, and then this shows that the MSE value difference. So for example, for the total case, there's not much difference because this is the first one to be tested. Then second, for new cases, we realized that upon adding new cases to our model, there's a negative 27 MSE value difference, so that's very significant. So same for new cases smooth, total deaths, the minus values, the negative values are here. For the other values, NSR stands for no significant reduction, so basically that it does not contribute much to the difference in MSE value, so we decided not to include it. As you can see from 0.3, so it's 16.99, and 0.12 is 16.18, so it's very insignificant reduction. So the last one we actually tested was new test smooth, which resulted in quite a good reduction in MSE values. So as a result, we decided to use these 5 features that results in significant difference. Why? Is because we believe that as the model grows in complexity, it will be harder to firstly get data for every feature. So it will be easier if we could use less features, and also that we could having less features also reduces our computational complexity, so to make the model run faster and better with lesser resources. Correct. So actually, although the R-square value and the mean squared error did not perform so well, the mean absolute value actually did better than our initial model. So lastly, we actually created back our initial model, and then we use this to test values to predict our model. So given these features with these numbers, we are actually able to predict to a very high degree of accuracy. Lastly, for our website, this is we are able to key in our features, and then you will be able to predict what the stringency index is. So for example, we'll put 10 here, 12 here, 14, 16, 18, let's say 5, positive rate 0.04, submit. So this will show the beta values that it was calculated from task 2. This will show the normalized values from the previous page. So this will calculate for us the final stringency index that we can see.